Alright, so here we are at linear programming worksheet number 3. I'll be doing 2 examples with you and then the rest will be for you to do. So let's go ahead and look at this problem. The cost to run machine 1 for 1 hour is $2. During that hour, machine 1 produces 240 bolts and 100 nuts. The cost to run machine 2 for 1 hour is $2.40. During that hour, machine 2 produces 160 bolts and 160 nuts. With a combined running time of no more than 30 hours, how long should each machine be run to produce an order of at least 2,080 bolts and 1,520 nuts at the minimum operating cost? Scale each axis by 3, which I have already done here. So don't forget, your x and y, your variables, should answer the question, which here is how long should each machine be run. So we'll say that x will be the number of hours for machine 1. And y will be the number of hours for machine 2. Okay, because this is a real life problem, again, we can always start out by saying that x has to be greater than or equal to 0 and y is greater than or equal to 0, which makes sense because the hours will not be negative, but the least we could run them is 0 if we didn't turn them on at all. Okay, so you'll notice we have bolts and then we have nuts. So let's look at just one piece of information at a time. Let's start out by looking at the number of bolts. Okay, so if we have let's talk about machine 1 first. It produces 240 bolts during an hour, per hour. Machine 2 produces 160 bolts in that hour. And we need at least 2,080 bolts. So with that information, we can say 240 times the number of hours machine 1 runs. That'll give us 240 bolts per hour of machine 1, plus 160 bolts times the hours of machine 2. That should be at least, so that means greater than or equal to 2,080. Now let's look at the information about the nuts. Machine 1 will produce 100 nuts in an hour. Machine 2 will produce 160 nuts per hour. But we need at least 1,520. So that inequality would look like 100x plus 160y needs to be greater than or equal to 1,520. It's these kind of problems that you'll get kind of stumped on, and usually it's because you need to break it down into individual categories. So one inequality for the bolts, one for the nuts. Okay, and then let's see. We need a combined running time of no more than 30 hours. So that means the number of hours for machine 1 plus the number of hours of machine 2 needs to be no more than 30 hours, so that's less than or equal to 30 hours. And just for the sake of space right here, for these equations, or inequalities I should say, again, we always need to solve them so that way it's something we can graph. This one, whenever I subtract the 240x and then divide by 160, when I get y by itself, I end up with y is greater than or equal to negative 3 halves x plus 13. So we'll be able to graph that one. For this other one here, when I solve that one for y, by subtracting the 100x and then dividing by 160, I get y is greater than or equal to negative 5/8 x plus 9.5. Sorry, that's a little messy. My stylus is kind of messing up. Okay, and then for this last one, when I solve that one for y, I'll get y is less than or equal to negative x plus 30. Okay, so let's start out by graphing the easy ones. X is greater than or equal to 0, and y is greater than or equal to 0. Okay, so I went ahead and did that. And I went ahead and put the arrows in, showing both of them going greater than or equal to 0. Okay, for the next one, my y-intercept, so we'll have negative 3 halves x plus 13. My y-intercept is at 13. So that means it's actually going to be a little bit in between. This is 12 and that's 15, so kind of just just above the 12. And then our slope is negative 3/2. So we'll go down 1, 2, 3 over 1, 2. And then that one will end up going off of the screen. 1, 2, 3, it'll be somewhere over here. But all we need are 2 points in order to connect them. So let me connect those. So for this one, y is greater than or equal to this line. So we need to have the arrows pointing towards the y values being greater. So it's going to be above. All right, the next one, negative 5/8 x plus 9.5. So our y-intercept is just above that 9 right there. It's probably too far. But we're going to go down 1, 2, 3, 4, 5, and then over 8. So actually, this one is kind of difficult because how do we know where to put our point? Okay, we'll say it goes off of the screen. We do know that if we're looking for a point over here on the y-axis, because we do need another point, well, the x-axis. The y-intercept was at 9.5. So then if I'm trying to figure out what my x-intercept is, I can plug in 0 for the y value. So if I just make that into an equation, I say, okay, what is my x value when the y value is 0? So then when you solve for this, you get negative 9.5 equals negative 5/8 x. And then when you divide by negative 5/8 or multiply by negative 8/5, you'll get x equals about 15.2. So that's where we're going to put the y-intercept. So now we have x-intercept. So we're going to connect our y-intercept with that x-intercept, and that will be our line. And then we'll be shading above this line because it's a greater than or equal to, so we'll be shading above it. So you can see we've kind of gotten rid of this little triangular corner, 2 triangles of corners. And then the last one, y is less than or equal to negative x plus 30. So then our y-intercept of 30, it's a nicer one, and then going down 1 over 1 since our slope is at negative 1. And then connect those. But on this one, it's y is less than or equal to 30, so we're going to have the arrows going down. Okay, so we need to look at the area where all of the arrows are pointing in towards the same direction. And then it's all of this going on over here. Let me trace that around in another color so you can see a little bit better. So it goes there, there, here. So we've got 1, 2, 3, 4, it looks like 5 sides, 1, 2, 3, 4, 5 sides to this shaded region, this feasible region for solutions. And that means we have vertices to go with that as well. So we have 1 right there, 2, 3, 4, and 5. So we have more vertices this time. So let's start listing these out off to the side here. For my vertices, I have the point, let's do the easy ones first. This was 0, and that y-intercept, if you can't remember, don't just guess, look up and remember, okay, that y-intercept was at 13, so we have the point 0, 13. Let's see, we also have 0, 30. We have down here, remember we solved for that one, and we got that is the point 15.2, and that y value is 0. We also have 30, 0. And then for this last one, if we had done a better job graphing it, it may have been easier to see, but it's kind of hard to tell where what this one, let me choose a different color here, what this point is. So what we need to do is take the 2 equations for those lines. So it's the negative 3/2 x plus 13 and the negative 5/8 x plus 9.5. And we need to set those 2 equal to each other and solve for x. So basically we're looking for their intersection, just like we've done for the systems of linear equations. So now this is kind of a review of old things we've done. Sorry, I should have chosen a different color there. But whenever we solve for x here, we'll end up with an x value of 4. So you would, depending on which order you wanted to do, you could subtract the 13 over and then combine the x values by getting a common denominator. And then you'll end up with an x value of 4. And then you would plug that back into either one, doesn't matter, and then you would get a y value of 7. So that means our last vertex here is the point 4, 7. So again, I just used solving systems of linear equations like we did in Unit 2 to figure out exactly what that point was. And you're probably going to have to do that too, so make sure you understand you're just looking for the intersection. So you can set those equations equal to each other and solve for that point. Okay, we do need to mention the objective function here before we do anything else. So our objective function, we're looking for the minimum operating cost. So say we chose C this time. C equals, for machine 1, that costs $2 per hour. So that'll be 2 times the number of hours for machine 1 plus machine 2 is 240, so 2.4 times the number of hours y. So if I plug, I'm sorry, these two things are on opposite sides of the screen, but I'm going to plug in all of these points over here into that function. So if I plug in the point 0, 13 in for x and y, I'll get the value 31.2. If I plug in 0 for x and 30 for y into my objective function, I'll get 72. If I plug in 15.2 for x and 0 for y, I'll get 30.4. If I plug in 30 for x and 0 for y, I'll get 60. But if I plug in 4 for x and 7 for y, I'll get 24.8. So we are looking for the minimum this time, so we want to choose the minimum value that we get for our objective function. So our smallest one here is the 24.8. That tells us then that for our solution, we need to run machine 1 for 4 hours. So machine 1 for 4 hours, and then machine 2 for 7 hours in order to minimize our costs and still meet the goals of how many nuts and bolts that we needed. Okay, that's number 1. Let's look at number 2. Okay, so Gino's factory packages bags of dried fruit. Gino has 75 pounds of apricots and 120 pounds of bananas. The apricots and bananas are to be mixed in 1-pound packages in the following way. A lower grade package should contain 4 ounces of apricots and 12 ounces of bananas, and a higher grade package should contain 8 ounces of apricots and 8 ounces of bananas. A profit of 35 cents per package will be made on the low grade mixture, and a profit of 55 cents per package will be made on the high grade mixture. How many packages of each type should Gino make in order to obtain the maximum profit? Okay, so our question here is asking how many packages of each type. So we could say that X will be the number of, we've got 2 packages, the low and the high grade. So X will be the number of packages for the lower grade, so the low grade. And then we'll say Y is the number of packages for the higher grade. Okay, now we need to list out our constraints. So, of course, X greater than or equal to 0 and Y greater than or equal to 0 right away, because we cannot have negative, but the least we could package is 0 of each kind. Okay, and remember, whenever it gets a little bit overwhelming like this, you're usually grouping it by category. So notice we have information about apricots. So we have 75 pounds of apricots and 120 pounds of bananas. So that's what we're starting out with. So first of all, let's take a look at just about the information about the apricots. Okay, so we know that we use 4 ounces of apricots in each of the low grade packages, so 4x plus. In the higher grade package, we use 8 ounces of apricots, so 8y. So the amount that we use total needs to be less than or equal to what we have available. Well, we have 75 pounds. But notice that the packages are in ounces, so we just need to multiply the number of pounds. We need to switch that to ounces, so we'll multiply it by 16 ounces. So 75 pounds times 16 will convert it to ounces, which if you wanted to, that's just 1,200 if you wanted to multiply that out. Same thing. Okay, so now let's look at the information about the bananas. So we use 12 ounces of bananas for each of the low-grade packages, so 12x plus we use 8 ounces of bananas for each of the high-grade packages, so 8y less than or equal to, we use 120 pounds, well we have 120 pounds total, again times that 16, in that case that would be 1,920 ounces if you wanted to convert that, or you could just leave it as 120 times 16. Okay, and then that's all of the information we have so far. So we need to go ahead and solve these for y. If I take this first one and I solve it for y, I will get y is less than or equal to negative 1/2 x plus 150. Then if I take this other one and solve it for y, I'll get y is less than or equal to negative 3/2 x plus 240. So I have four things I'll need to graph. X is greater than or equal to 0, and y is greater than or equal to 0. Y is less than or equal to negative 1/2 x plus 150. And y is less than or equal to negative 3/2 x plus 240. And then, of course, we'll have our objective function in the end, but let's go ahead and write it. We are looking at our profit. So we'll say our profit, we make 35 cents per package of the low-grade mixture, so 0.35 times the number of packages of the low grade, plus we make 55 cents profit times the number of packages we get of the high grade mixture. So we'll come back to that one in just a moment. But for now, let's again graph the easy one. X is greater than or equal to 0, and y is greater than or equal to 0. Okay, and then I've gone ahead and drawn my arrows in to show which direction I will end up shading in the end. My next one, let's graph the line negative 1/2 x plus 150. Okay, so here's 140. The next one would be 160, so 150 is right in the middle. And then my slope is negative 1/2, so I'll go down 1 over 2. Just like that, and connect. And then for this one to shade, we'll be shading below because we have a less than or equal to, so we're going to be shading on this side of the line. Okay, and then the next one, negative 3/2 x plus 240, so my y-intercept is 240, and my slope will go down 1, 2, 3 over 2. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and connect that one. So we'll be shading less than or equal to, so below this line. So I'll put my arrows going that direction. Okay, now I can see which area has all of the arrows pointing into the same region. So that's all of this section right here. There are 4 sides to this shaded region. I'll pick another color so you can see it a little bit better. Trace it so there's 1, 2, 3, and 4. So my 4 vertices, 1, 2, 3, and 4. Okay, so I need to start listing those out. Easy ones are 0, 0. Then we've got 0, 150. And we know that's exactly 150 because that y-intercept was at 150. So 0, 150. We have 160, 0. And then for this last one, if you're not really sure where it's at, don't forget you can just take these two equations and set them equal to each other. So let's do that. So this one was the negative 1/2 x plus 150. And then this one was the negative 3/2 x plus 240. If we want to get rid of all of those fractions, we can multiply everything by 2. So we'll have negative x plus 300 equals negative 3x plus 480. Okay, so then if I add this 3x over, negative x plus a positive 3x is 2x. Then if I subtract the 300 over, that's 180. So then when I get x by itself, x will equal 90. 180 divided by 2 is 90. And then for the y value, I just need to plug that back in. So if I chose the first one, 1/2 times 90 plus 150. So we have negative 45 plus 150, so that's 105. So then that tells us that that point is at 90, 105. Okay, now we just need to plug in each of these values. So if we plug in 0 for x and 0 for y, we'll end up with making 0. If we plug in 0 for x and 150 for y, we'll make $82.50 in profits. If we plug in 160 for x and 0 for y, we'll make $56 in profit. And if we plug in 90 for x and 105 for y, we'll make $89.25 in profit. Well, we were looking to maximize that profit, so then the largest one would be $89.25. So that tells us that we need to make and sell 90 low grade packages, and we need to make and sell 105 high grade packages. And that's our answer. Alright, so the rest of this worksheet will be for you to do. If you have any questions, let me know. Hope you're having a great day. Bye.